Greetings viewers, I'm the Smithy99999 and welcome back to Science Mondays. Today's topic, black holes. Now this will be a quick one and we won't go into too much detail about black holes because it is quite a challenging subject when you look at the physics behind black holes. In fact, it's a very, very complicated one which I don't believe anyone's actually solved properly, as singularities, which is what is at the core of a black hole, are a very, they're just not very well explained by our current understanding of physics, as it requires a melding of quantum mechanics with gravitational theory, which just hasn't worked so far. So to keep things simple, I will primarily be talking about misconceptions the media and public at large have about black holes. For one, they are not the giant vacuum cleaners of the sky. They, like any other stellar object, can be orbited when you are at a sufficiently large radius. The only time that you get sucked in is when you cross what is known as the event horizon of the black hole. So if we were to say take our solar system and replace our sun with a black hole whose event horizon is less than the radius of the orbit of Mercury, you would only get a change in light and radiation received at Earth rather than the Earth suddenly gets pulled in. Now that I've been distracted, I could get on to talking about what a black hole actually is and how to discover them. A black hole is simply a dead star whose gravitational field at the surface prevents light from escaping. That is, it is greater than 3 with 8 zeros after it meters per second. As light cannot escape from the surface of a black hole, this makes detection tricky and near impossible via direct observation. So one method is looking at binary systems which are emitting in the X-ray spectrum. Now, the theory is that one of the stars of this binary system has collapsed and become a black hole and is accreting mass off of its partner star. One strong candidate for a black hole determined via this method of looking is known as Cygnus X1 and was discovered in 1972. There are, however, some uncertainties resultant from the companion star actually being heavier than what they believe the black hole is. Another method of finding black holes is to look at the orbits of many stars around a certain area. Now, for instance, in the area Sagittarius A star in our own galaxy, the motion of 90 stars was fitted to Keplerian orbits, and they have found that they orbit something which has a spherical mass of 4.3 million times the mass of our own Sun. And this mass is contained within a radius of less than 0.002 light years. Now, this radius is 3,000 times larger than the Schwarzschild radius for this mass. Now, a Schwarzschild radius is the radius of a sphere such that if all the mass was inside of it, would have an escape velocity on the surface which would equal that of the speed of light. Now, this does mean that it might not be a black hole. However, it is also important to remember that there is no realistic way for a cluster of stars equal to that mass being in that small of an area. Other galaxies with theorized supermassive black holes at the center are the Andromeda Galaxy and the Sombrero Galaxy. Now, these are just two methods of searching for black holes, and there are many more methods out there, such as gravitational lensing. However, I do not have the time nor the skill to actually explain some of the more complex and go into further detail in these methods, so I will leave it here. I've been the Smithy99999. This has been Science Mondays 3 Black Holes, and goodbye. When you can't actually you can't see the actual event take place. On the other side, don't take the fact that it is an incredibly educated guess using the knowledge